Okay, suppose see I'm having EMP table. Listen, okay, see important topic. I'm trying to create one table, EMP 13, ID, number, name, varchar, city, varchar. Okay. So see, this is important topic. City, varchar. Okay, like it up. Okay. So where I should create this object? Where I should create this object?
In database.
Okay. So in that, give me 1 minute, please. 1 minute.
Sir, you are on mute, sir. Sir?
1 minute, please. 1 minute. Tell me where I should create this object in Snowflake database. Okay, so tell me, let me open one SQL sheet. Tell me it work.
We need to select the database.
Okay, we should select. Okay, see, so like let me create one database. So create database. Tell me in real time who will create these databases and schemas, which guy?
Snowflake admin.
Snowflake admin. So create schema. Schema. Okay. Tell me by using query, I want to find what is my database name and what's my schema name.
Select current database.
Current database and current schema. Okay. Same thing. How to get list of tables?
Show tables.
Show tables. Okay. Show tables. Okay. So by default, show tables. Okay. Current schema. So these are basic things required for the topic. Schema. Okay. Now see table database is there. Now create the table. Now see question is that what? Now what's the default size for I number and varchar? So we did not mention any size. What is the default or maximum size for ID number and varchar? Important thing. Anyone? So how to see list of columns? List of columns.
Describe table.
Describe table
name. Okay, see point is that what? See, if I mention 10, the size is 10. If I don't mention what's the maximum size it will take, see, describe table name. So maximum size for number is 38, 0. What about this value? It is something like this. What is value, anybody? What is value?
16 MB.
So it's a 16 MB. It's a simple thing. So select 16. 1 MB is nothing but what? 1024 kilobytes. 1024, 1 KB is nothing but what? 1024 bytes. So see, point is that what? Maximum for number is 38, 0. For varchar is 16 MB. 16. Let me populate some data into EMP13 values. So 1, Ravin, Hyderabad. Same thing. 2, Kumar. 1 second. I want to get constraints. Okay. Let me put constraints also. So create or replace table. Okay. Tell me in Snowflake, what are the constraints we can create? In Snowflake. Okay. See what are the constraints we can create. Tell me. Create.
Not create. We can create everything.
We can create what are the constraints? Not null, unique key, primary key, foreign key, and the default. Which constraints is getting enforced?
Only not null.
Default and not null.
Only default and not null constraint. Okay. So I'm trying to create one table with the following constraints, not null. So create the table. Okay. So 1, 5. Okay. So see the data. So Chen. Okay. See, table has been created with the two records. Select star from EMP15. Now requirement is that, no, what's my requirement is that what? So this is my table. I want to take a backup of the table in Snowflake. See, normally tell me in SQL how to take a backup. Based on which concept?
CTAS.
Okay, see, point is that what now we're discussing. So how many ways I can take a backup of a table in Snowflake. Okay, so we know what? We know one is CTAS. What is CTAS syntax? So create
table name as
so create
select.
table name as select star from old table. So see, this is the syntax. Okay, CTAS. So go back here. So create table name. What's our table name? So EMP15, something like I'm putting CTAS as select star from EMP. So important, listen a little bit carefully. So concept will be, okay, see. So this is my concept. Okay, now I'm trying to create the table. Okay. Now how to see the definition of the table? What is the definition of the table?
Get DDL.
Select get DDL. Okay. So bracket open, bracket close. So table and the table name. Okay. So table. Okay. So see the same thing. So this is the main table. Control C, open SQL worksheet. Okay, Notepad++. So this is create or replace table. So see constraint, not null, and a primary. Same thing. Let me take the backup table, EMPC test. Copy the same thing. Control and Control V. Okay, see Notepad++, we can able to compare to Notepad++. Okay, now tell me. Now what's difference? What is the difference? This is the main table and this is the backup table. That is CTEST table. What's the difference?
Primary key.
Primary key is not enforced and only not null.
Not enforced. Okay, see constants are not getting populated. Okay, so see here, tell me. So here constants are there. Here constants are not populated. Tell me what is difference between CTEST? Okay, so see definition is there plus no constraints. No constraints. What about data? How to see the data? How to see data? By using select statement. Select star from this thing. Okay, so I'll try to explain what exactly we're trying to do. So if you take a backup, we are getting the definition plus no constraints. What about data? Data is getting populated. Okay, so this is fine. Okay, so one way is by using CTAS. Other way is that what we're having one more way, that is like concepts. So you see, as of now, we're discussing how many ways I can able to take a backup. One is CTEST, other is the like syntaxes. So create table name like old table. Okay, see this is a syntax. So create table name. What's our table name? Table name EMP. We can put EMP15 like is the keyword EMP15. So see, from the EMP15, I am trying to take a backup. This is one more way. Okay, now see the definition. So see the definition. Control V, Control Enter. Okay, copy the same thing. Control C. Go back here. Okay, compare one more time. And tell me what any difference between there from main table and the like table. Any other difference?
No.
Okay, only which difference? Only name is different. So constants are also getting populated. Okay, see the same thing. So Control D. So see definition plus constants also getting populated. What about data? How to see data by using what? By using like. I can see select statement. Now tell me data is there? Tell me. No. So see by using like we can get the definition, we'll get the constants, but no data is available. No data is available. So this is important. So definition, no constants plus data. Sometimes we want to create the table without data. Then go for like concept. So one more concept is that what's the other concept? Important concept in Snowflake. Tell me.
Clone.
So clone is the concept. See clone. So by using clone, we can able to take a backup. Okay, see clone. Go back here. Go to Snowflake. What is syntax? Syntax is what is syntax? Okay. So create
Table.
so
Table
table.
name.
So table
Table.
name. Okay.
Clone.
Instead of like put the clone old table. Old table. Okay. So create table name clone old table. Okay. See one more time. So this is important. We'll see the what background happening. So create table. So what's our table name? So see EMP15. EMP15. Okay. Clone. What's our table? Main table EMP15. See the same thing. So let me go back here. Take the same thing. Take the definition. Control V. Control V. So control enter. Now see what happened. Copy the same thing. Definition. Go to Notepad++. Control V. Compare. Okay. Tell me what's the difference? What is the difference? Any difference is there?
No.
No. Okay. See, no difference is there. So see the same thing. Let me take this value. Now see when I go for clone, what happened? So see, we'll get definition plus constants is populated. Constants also getting populated. Okay. What about data? See the data. Data also populated. See. See, point is that what with the help of clone, definition plus constraint plus data is also populated. Okay, now important point is that what? Okay, see, so see, cloning is also called as zero copy cloning. I'll explain the background. So zero copy cloning. Okay, see your point is that what if I go for normal EMP main table. So see, main table will have definition. So see, definition plus constraints plus data plus storage. Tell me when data is there, what happened? Storage will be there or not for main table?
Yes.
Storage will be storage will be storage. What about sheet also have storage
Yes.
cost will be there. What about like any storage? Anyone?
No.
Why?
Only definition.
Since
No data is
so no data, then we have no storage will be there. Okay, what about clone?
zero.
No storage.
No storage. We'll see the same thing. So this is important point. Okay, so whenever if I want to take a backup, we'll go for cloning because it doesn't have any storage. I'll explain in detail. So see, cloning is also called as zero copy cloning. It means that what without any additional storage, we can take a backup of a table. Okay, I'll explain in detail. So before that, if you want to understand this functionality, you should have knowledge on Snowflake architecture. I will explain in detail. So this is important. So see, point is that what I'm having 1 GB data. Okay, so now I want to take a backup. Tell me which type of approach is preferable for this one. We'll go for cloning because it doesn't have any storage. Okay, how can we can able to understand? Okay, tell me Snowflake architecture, how many layers are there? Anybody, any guess? Those have prior knowledge. Okay, 3 layers are there. Okay, see. So see, there are 3 layers are there. What are the 3 layers? Storage,
metadata,
computation, and cloud service. Okay, so there are 3 layers in the see Snowflake architecture. One is cloud service layer. Other one is that? What is the other one?
Metadata layer and storage layer.
Not metadata layer. Okay,
compute
so
layer and
compute layer and storage layer. Okay, see cloud service layer, computation layer, and storage layer. Okay, now see the simple thing. Let me copy all this thing and put here. So there are 3 layers are there. Cloud service layer, computation layer, and storage layer. Okay, see the same thing. So here, see, this is the virtual warehouse. As of now, I am putting in suspend status. See, suspend status. Now I am trying to create one table. So create table EMP77. Okay, ID number. Okay, see the same thing. I have created one table. Now see, when I create the table, now what happened? Tell me. Computation power. This is what's in which status? It's in suspend status. Okay, see, point is that what? Whenever I create any table, which layer come into picture out of these three layers? Which layers can come into picture? Anyone in here? Important?
Compute layer.
Cloud service.
No, see, not computer. So see, whenever we create any table, so see what happened. The cloud service layer will come into picture. Okay, see now this data will be stored. The table information will be stored by this metadata layer. So one more time. Whenever you create any table, what happened? So see, so cloud service layer, the metadata, the number of columns, okay, the table name, the all the information will be stored by this metadata. So first step is that what? When we create any table, what happened? The table information will be stored by what? Only this method, that is cloud service layer. See, cloud service layer. Now, still it is in which status? It's in suspend status. Now I want to perform, okay, so I want to populate this data. Tell me, how can I populate data by using what? By using insert. Okay, insert into table name values. Okay, so this is what statement? This is what? This is DML. So this is DDL statement. Okay, so this is important point. Now I am trying to insert into EMP77. See? Okay, now see this one. What happened? The status? Status changed to what? Let it is suspend status. See, so suspend status. Let me insert second record. Now what happened? Tell me, status has been changed to string to started status. So point, tell me, anybody can able to tell? I'll try to explain what happened here. What happened?
Auto resume the warehouse.
Okay, see. So see, point is that what? So point is that what? Whenever we perform any DML or DRL, okay, so compulsory should require computation power. Computation power. Nothing but what? The CPU, RAM. Okay, who will provide this all these things? The virtual warehouse. So see, this is one more time. Now, point is that what? Now I want to store this one record. Before that, tell me, this data will be stored where physically? In which layer? In which layer?
Storage.
Storage layer. See, storage layer in the form of micro partition. See what happened whenever you perform any insert. No, the data will be stored physically in the storage layer in the form of micro partition, small parts. Now tell me now, if I want to insert this data, we should require what? We should require computation power. Computation power will be given by which guy? Given by which guy? The virtual warehouse. Okay, see one more time. If not able to understand, let me suspend this warehouse. Okay, suspended. Now I am trying to create so tell me. So tell me, create is a DDL statement. Does DDL require computation power? No. So DDL statement, okay, doesn't require computation power. Okay, see computation. Okay, see, this is the point. Now tell me now this table definition, who is holding, which guy is holding out of these three layers? Tell me, out of these three layers, who is holding?
Cloud service.
Cloud service layer. By which guy? The metadata guy. So metadata guy contains what? The table names, number of columns, column size, this all the information will be stored, the number of record. As of now, how many records holding? Holding 0 records. Okay, see the table information like 0 records it is holding. Okay, so 0 records it's holding. Now question is that what now? DDL doesn't require any computation power. Now I want to populate this data. Okay, see, populate nothing but what? So data need to store where? Physically where? In which layer? In which layer?
Storage layer.
Storage layer.
In the storage layer, in the form of micro partitions. Okay, now if I want to insert this data, what require? Which require computation power. Computation power given by which guy? The virtual warehouse. It's like cluster of machines. Simple thing. What happened now? I want to take this two data and store physically. Now, how can I store which require computation power? Let's say, see what happened. So see, it's in suspend status. Now see, auto resume nothing but what? Whenever I perform any DML or DL, it will get automatically resume. See, I'm performing insert statement. Okay, see. So see the same thing. Okay, see. Started. So see the point is that what DMLs require computation power. Okay, computation power by given by which guy? The virtual warehouse. Okay, now so with the help of virtual warehouse, the data is populated here. Now again, this information is holding by what? This information is holding by which guy? The metadata guy. So see, point is that what I'll having 0 records. Now, how many records is holding right now? It's holding 1 record. This information is holding by which guy? The metadata. So metadata is nothing but what? Number of records. Okay, number of distinct records. Okay, total number of records. In which partition this all the information will be held by this metadata. Data about data. It contains the partition information. Remember, actual data is storing here. This information is holding by which guy? The metadata. Got a point one more time. So see, so whenever I create table, now warehouse. Okay, which guy will come into picture? Cloud service layer. Okay, in this layer, metadata guy. So metadata management. Okay, so this guy will contain what? Contains. So table name. Okay, column names. Okay, column size, number of records, and partition information it contains. Okay, so physical data will be stored where? Tell me, physical data will be stored in which layer? Physical
Storage
layer,
layer.
in the storage layer, in the form of micro partition. Now what happened now? I'm trying to insert one more record. When insert one more record, what happened? Tell me now. This so data will be physically stored with the help of this virtual warehouse. Again, this information is holding by which guy? Now it contains 2 records and the partition information is getting. Got the point? This is important. If we're able to understand this concept, the cloning will be simple. Okay, see, actual data stored here. This information is stored by this guy. Got the point? So this is the cloud service layer, computation layer, and the cloud storage layer. See one more time. So cloud service layer contains the authentication, authorization, and the metadata information. So next layer is it's a virtual warehouse. The CPU, RAM, the computation power by given by virtual. If I want to process, if I want to insert, or if I want to fetch data which require computation power. Next layer is nothing but what? Storage layer. Storage layer is nothing but what? The data will be stored physically in the form of micro partition. This is clear so far. So this is fine. Now come to the topic. Now when I go for normal C task, so this is important. Let me open the paint. So listen, okay, see, so it will take a little bit confusion. Okay, see. Okay, let me open this table. Assume that this is the employee table. So see EMPT. Okay, so it assume like it contains EMPT 100 records. Okay, 100 records nothing but 100 MB storage assume like okay, 100 MB storage. Okay, see, so this is my employee table. Okay, it contains 100 records and 100 MB storage. Now what happened now? I want to take a backup. Okay, see backup. Control C, Control V. Okay, now what happened? Tell me now storage will be what? Storage will be so 200 MB. Now it will be what? Now how much storage it has? Contains 100 MB, 100 MB, 300. So this is normal CTAS concept. If I take a backup, what happened? There will be separate storage, separate. So totally 300 MB storage. Now same thing. Let me open to the paint. Okay. So Control V. This is important logic. Okay. See. Control. This is main table. Okay, now I want to take a backup with the help of clone concept. See what happened. I am trying to create one more table. So one more table, one more table. So 3 tables I have created. Okay, see, but what happened? See, now this all 3 tables will be pointing to the same thing. Okay, see, we can take n number of backups, but storage will be single storage. Okay, I'll explain what exactly happening. Okay, see. So this is the main table. I am trying to take a backup. So this is one table, second table, third table. So three tables having pointing to here. So see, now there will be no storage cost. Okay, see this tables contains what? Okay, only so see only metadata. Okay, see metadata information of micro partition. So see point is that what? So see this contains, okay, so this objects contains only metadata informations, not the actual data. See one more time. When I take a backup, normally what happens? So physical storage will be there. So three tables will have that 300 MB. But when I take a back, now see what happened. There totally four tables are there. Out of four tables, only the main table contains the storage. Remaining all three tables contains only metadata information. If you're not able to understand, let me help you. The same thing, simple thing. See here. So see this image, you'll get some clarity, then we can proceed. Okay, see. So see this information. Okay, so this is the main table. So main table tell me now main table contains storage will be there in the which layer? In the storage layer. Our data will be stored in which layer? In the micro partition. So P1, P2, P3. So three partitions are there. Okay, now when I take a backup with the help of CTAS concept, what? So again, storage will be there. C1, C2 separate partition. So in the sense like what? There is separate storage cache will be there. But when I go for cloning, see what happens. See this image. So this is important. See this image. So see this image. Now what happened? Tell me, can anybody tell me what exactly happening? What exactly happening? Anyone?
Without storage, it will
Storage,
be.
storage is not
Okay, see now what
separate.
happened? See, storage will be single storage, but what exactly we are copying? We are copying what?
Metadata information.
We are copying only the metadata information.
Okay.
Actual data is storing the storage there, but we are copying only the metadata information of micro partitions. See one more time. So this is our table data, but what happened? So we are trying to create one more table. Now see here what happened? We are taking only the micro partition information, not the actual data. So see one more time. So taking only the metadata information of micro partitions, not the actual data. But when I take this now this table backup, nothing but what? Again storage cache. If I take 10 times, what happened? So 1000 MB will there. But when I go here, what happened? There will be only 100 MB. This all these three tables are pointing to this same storage. This is the function of storage. Okay, see, okay. So without any additional storage, we can able to take a backup. So see, what's the conclusion here? When I go here, go back here. So see, storage will be there. What about storage? Storage, no storage, no storage. Tell me why it's no storage? Because it's a metadata operation. What about your storage? Because so with physical data we are trying to copy, but you're copying only the metadata information. Okay. Now this is clear so far. Ask a question. I'll try to explain. We'll go for one more thing. Anyone? Go ahead.
In cloning concept, we are
Mm.
just copying the metadata, right? So in that case, in main table, if I have modified some data,
We'll say
it's
that
the
one.
same data.
I'll explain it.
Okay.
Is this clear as of now? See, point is that what see. So see these two images, you'll get some clarity. So here what happened? So see storage, CTS, separate cache. So no storage, no, so there won't be. So that's why we'll go for suppose I'm having one EMP table. It contains 1 GB data. Now which one I should go for if I want to take a backup? Go for cloning because no storage cost. No storage cost. Okay. Now one more important point is that what? Let me go back to the EMP table. Now I want to take a backup. Tell me how to take a backup. We'll go for CTAS. Now make it to suspend status. Tell me CTAS syntax. Create table.
Table name
Table name as select star from the same thing. Now question is that what does it require computation power or not?
No.
No, yes or no?
Question is not
Not required. Huh?
not required.
We'll see the same thing. Okay, now see what happened. So see this. Okay, query profile. See the query details. Tell me it's using warehouse. Huh? So see, remember point is that what CTAS require virtual warehouse. Okay, what about this one? Like
No.
no. Okay.
Required.
What about clone?
No.
Clone. We'll see the same. This is important point. Okay, see, let me copy the same thing. So create table. Okay, so CL clone. Now see the same thing. Click on this values. View query profile. So query details. Tell me it's using a. So it said like I see. Want is that what? No virtual warehouse required. It's a only metadata operation that doesn't require any computation power. What the point? I see one more time. So see. So if I perform CTES, there'll be storage cost and the computation cost. What about cloning? No storage cost and no computation power. So zero copy cloning is nothing but what without any additional storage and without any computation cost, we can take a backup of a table. So this is the definition. So zero copy cloning without having any storage cost and computation cost, I can take n number of backups. This is one important feature in Snowflake. Okay, go ask your question. See, so see there is no computation cost and no storage cost. We can take n number of, if you want to perform any testing or if you want to perform any backup, we'll go for what? Go for zero copy cloning. Compulsory they'll ask the question. So why it's called a zero? Because it doesn't take any storage cost, any computation cost. We can take n number of backup tables for testing purpose. Got the point? Huh? Isn't it getting a little bit?
Yes.
Okay, so this is fine.
Yeah.
Okay, now see the same thing. Now your questions now, what are asked now, we'll see discuss same thing.
What about micro partitions?
Micro partitions, come again? No, see, we are not, see, actual data is storing sitting here. Okay. So only are copying the metadata information on. We'll see the same. Your question is like this again. 1 second, let me complete the questions. Tell me what is cloning? It is used to take a backup or snapshot or replication of a table. Now I want to clone, tell me we want to clone only tables. Huh? We can clone schemas and a database. Tell me how to clone the schema syntax. Create schema name, clone old schema. How to take the database backup? Create database. So database name, clone old database. So this is fine. Okay. Next one is that what? Tell me why cloning is called as zero copy cloning. Tell me.
Because it doesn't take any storage.
So no storage and no computation cost. Okay, how can you prove? We can prove by using computation. Okay, so in which situation have you used cloning your project? Tell me.
When we have a release
backup tables and do some testing on them.
When you want to take a backup, okay, or if you want to perform any testing, okay, instead of applying on the main table, you can take a backup by using cloning. Does cloned object we'll see the same thing. When you make any change to the cloned object, does it get base table or not? Okay, see, now question is that what? Let me go back here. Go to the Snowflake. Now see what happened. Now how many records are there here? Select the star from EMP7. Okay, it's 2 records. Now what happened now? I want to take a backup. What is syntax? So create table. So CLO clone the same thing. Now how many records it contains? Tell me. This also contains how many records? How many records? 2 records. Okay, see, select star from the same thing. Okay, see here 2 records and here also 2 records. Okay, see, so far good. Now point is that what? Okay, see, point is that what? When you make any change to the cloned object. Okay, let me insert one record. So insert into clone, important. So I insert 5. Okay. Now in the EMP77 clone, we'll get how many records? So 3 records will be there. What about this one? We'll get 2 or 3? Anyone? Why 2?
That is separate object.
That's the
So see,
main.
point is that what, see, so when you perform anything, so see, when you make any change to the cloned object, so see, both are independent tables. So see, at this particular point of time, both are having the same storage. So it will have same. When you perform anything, what happen? No changes will get reflected. So both are independent. Suppose see, let me insert one more record in the main table, 50. We'll get 50 data will be coming here. Okay. What about here? It should come 50 data? No, because both are independent to each other. See, answer is so no. So the change will not get reflected because both are independent table. Okay. So now tell me next question is that what? Okay, see, a new record inside the clone table, does it have storage or not? Suppose see, I insert a new record in the storage table. Okay. Storage table. Okay. So 500. Okay. Now question is that what? Does it have storage or not? Tell me.
Yes, yes.
So see, point is that what at this particular point of time, no storage. When you perform anything, what happen? So data will be stored physically in one more layer. See, this is nothing but what? So our data will be stored in separate micro partition. So because now what happened at this particular point of time, both are having same storage. Now when you perform any change, what happen? There will be separate storage will be there. See, answer is that what? A new record in this clone table. Yes, answer is yes. Is stored where it will be stored in the new micro partition. So this is the part. Okay, guys. Can you perform DML operation on the clone tables, sir?
Yes.
Yes. How will impact original tables?
No impact.
No impact because both are having
individual.
both are independent to each other. So there is no dependency. So now question is that what? Now we are saying what we are saying. So it's a zero copy cloning without any storage. Okay, so without any storage. Okay, now we discuss what? So zero copy cloning is nothing but what? Without any additional storage, we can take a backup of the table. Now question is that what? Now how can you prove that doesn't have any storage? Okay, so theory is fine, but practically I want to say like zero copy clone doesn't have any storage. Now how can you prove, anybody? How can you prove?
Can you see the properties of the table?
Okay, so properties not, we need to check what? We should check the one view is there. What is that view? Select star from. So information schema dot table storage. This is very important. Table storage metrics. So we can able to figure out. So by this, we can able to check it doesn't have any storage. Okay. Now let me create over the table name. EMP. Okay. Tell me, I want to get table starting with EMP15. I want to get table name starting with EMP15. How to get? Like. Okay, see EMP. So see, totally 4 tables are there. Okay, see 4 tables. Okay, let me take the screenshot. This is important. Listen. Okay. So EMP15 like EMP15 see it as clone. Out of these 4 tables, tell me which tables are main tables for your perspective. Tell me which tables are main tables. Anyone?
15.
How can say?
EMP.
Okay, 15 is the main table. Remaining are? Anyone tell me? Let's see one more time.
Backup.
So like I'm putting EMP51, 52, 53, 54. Tell me. Now see the data. See the data and tell me which is the main table.
2 and 3.
All are main tables.
Not all are main tables. One table is not main table. So see the same thing. Tell me.
Okay.
ID both are same.
Yeah, same.
This is same. Okay. So what about this one? Same. Same. Okay. What about this one? Same. Same. What about last one? Same.
Not same.
Okay. Now it's pointing to what?
266.
So pointing
The
to?
fourth is pointing to second one.
second one. So see, point is that what see? So when ID, clone group ID both are same, it's a main table. So main table. When both are different, so what? It's a cloned table. It's getting cloned from what? Cloned from EMP15. So see, this is important. Now see, assume like, okay, see, this is one important thing. Let me open one more. So let me take the screenshot one more time. Okay, now see employee clone, see test, like out of this 4 table, which tables are main table? Employee table, see test table, like because both are same, it's a main table or base table. Now what about clone, which having different thing? Okay, now see it's a store, it's different. Now point is that what? So employee is having 3584. Assume like 10 records are it's acting 3584. Now if I go for C test, data will be there or not? Yes or not? Data will be yes, because we discuss. Okay, what we discuss? It will be separate storage cache will be there. Separate storage cache. What about like storage will be there? What about like
No storage.
no, because
Only
no, there is no record, no storage, only metadata. What about clone? What about clone?
no storage.
No storage. That's why it's having 0 bytes. Now by using information schema dot table storage matrix, active bytes will be 0. It's nothing but it's having 0 storage will be there. One more time, if you're not now tell me out of these 4 tables, okay, see, so now as of now both are having all are having 0 bytes. Okay, so why? Because there is 2 hours latency. What is latency? Some delay to populate in this table. Okay, in this table. Now question is that what after 2 hours data will be populated where in which thing? Like will be there? Huh?
No,
No. What about main table?
it will have.
It will have. Suppose like 100 is there. Okay. What about CTS?
Yes.
It will
100
have.
is there. What about clone?
0.
No. See, so see, because now only CTS and the main tail have data will be populated. What about clone? Because it's a 0 copy cloning, it doesn't have any storage will be there. See one more time, so you can able to do. So see, create table with constraints, insert 5 records, CTS, like, and clone. So see syntax understand. After 2 words, check in information schema dot table storage matrix. What are the columns? ID, clone group ID, active bytes. Tell me, so okay, after 2 hours, data will be populated where in the CTAS or in the like or in the clone in the main table as well as in the CTAS table. So CTAS table. So now what about clone? So ID and clone group ID will be different and active bytes will be 0 because it doesn't have the extra storage. Okay, see no storage cache, no computation cache, we can take a backup. This was a function. So see, so with the help of 0 copy cloning, we can take n number of tables without any storage cache and computation cache. How can you prove? We can prove by using what? By using information schema dot table storage matrix. ID, clone group ID will be different. This ID will be populated from the main table and active bytes will be 0, 0. Got the point? Huh? Getting a little bit. So this is called as 0 copy cloning. Without any additional storage, we can take n number of copies. So this was the function. Ask a question.
Praveen,